So this is OCR's foundation paper. It's the paper 2 non-calculator from June 2019. And if we have a look at the grade boundaries, we need 50 marks for a 4 and 66 marks for a 5. Question 1, and here we've got just some decimals to add together. I'm going to do £4.25 added to £5.18. All you've got to do is make sure your decimal points are lined up. 5 add 8 is 13, 2, 3, 4, and then 4 add 5 is 9. £9.43. Part 2, we're just negative 8 add 11. If you struggle with these, just think of a number line. You're going to start at negative 8 and move 11 that way. Negative 8, add 8 gets you to 0, and there'll be 3 left if we're adding on 11. And then we've got to do negative 6 times negative 9. Well, 6 nines are 54. A negative multiplied by a negative is back to a positive, so 54 is fine there. Part B, just looking as inequality symbols, looking whether these things are equal or which is the bigger one. Remember, these are like crocodiles, and crocodiles eat the biggest number. Be careful with this one. If you're looking at comparing decimals, make sure you make them the same length by adding zeros on, and then we can see that 4.50 is bigger than 4.34. 3/4, just knowing that that is the same as 0.75 makes these easy to compare. So 0.75 and 0.80, this would be the bigger thing. And then again, just thinking about what 3/5 is. 3/5, how many 5s go into 3? The answer is no. Well, it's actually no remainder 3. And then how many 5s in 30? The answer is 6. So 3/5 is 0.6, and 0.6 equals 0.6. Question 2, it says, by rounding each value to one significant figure, estimate the cost of 3.9 kilograms of apples at 87 pence. Don't forget this rounding, so 3.9 kilograms becomes 4 kilograms, and every kilogram is 87 pence. Well, one significant figure would round that to 90 pence. So now we need to do 4 lots of 90. Well, 4 nines are 36. Don't forget to add this 0 on the end, so 360 pence, which is £3.60. Question 3, completing each statement. We're looking at equivalent fractions here. So how have we gone from 7 to 28? That's an equivalent fraction where you've times by 4. So we'll have to do the same on the top, and 3 times 4 is 12. Part 2 says turn 4.5 into just halves. So we're turning the mixed number into an improper fraction. I'm going to do 4 times 2. 4 times 2 is 8. And add this 1 on. We've got 9 halves. Part B, just subtracting fractions. Well, remember, when adding or subtracting fractions, we need a common denominator. And the easiest way to get that is by just multiplying denominator together. So 3 times 5 is 15. We're going to work in 15ths here. I times this by 5. So this gets times by 5. 2 5s are 10. I times this by 3. So this is going to get times by 3. And 1 3 is 3. And then 10 15ths take 3 15ths is 7 15ths. Question 4, we've got to do 0.7 times 0.3. Well, if we work out 7 times 3, we know that comes to 21. And if we're going to work out 0.7 times 0.3, we know that it's going to have a 2 and a 1 in the answer. We just need to figure out where the decimal point goes. There's a sneaky little trick here. If you find your decimal points and count how many digits after the decimal points, so decimal point 1, decimal point 2, there's going to be 1, 2 digits after the decimal point. So this would be 0.21. And then down here, part B, we've got to do 0.48 divided by 6. Well, if we do 48 divided by 6, we know that that is 8. 6 8s are 48. We've now got to do 0.48 divided by 6. So it's going to be an 8, but I've just got to figure out how much bigger or smaller this is going to get. So 48 divided by 6 is 8. Look at this, what I'm actually trying to divide. This is much smaller than 48. And in fact, it's 100 times smaller. So I need to divide this 8 by 100. And if we divide it by 10, we get 0.8, and then by 100, we get 0.08. Question 5, complete the following. 5 squared is just 5 times 5, which is 25. The cube root of 64, well, we're looking for a number where you times itself 3 times, get 64. So we've just got to try some numbers. And if you do 4 times 4, that is 16. Multiplied by 4 again is 64. So the answer to the cube root of 64 is 4. And then final part of this question, we're just going to do 2 cubed. Well, 2 cubed is 2 times 2, that's 4. Times 2 again is 8. And we're multiplying by the square root of 49. 7 sevens are 49, so the square root of 49 is 7. And 8 sevens or 7 eighths are 56. Question 6, and here we've got a function machine, so we're timesing by 5, then taking 3. And it says found the output when the input is 7. So 7's going into this machine. We're going to do 7 times 5. 7 5s are 35. Then take away 3. 35 take 3 is 32. So 32 comes out of the machine. Part B says find the input when the output is 42. I'm just going to clear this off. We know now that 42 is the output and we're working backwards. So if you're working backwards on a function machine, you need inverse operations. So take 3 becomes add 3, and times 5 becomes divide 5. 42 add 3 is 45, and 45 divided by 5 is 9. Part B says the input is x and the output is y. Write an equation for y in terms of x. So because it says y in terms of x, we need to start y equals, and then just figure out what happens as x goes into this function machine. So just clear this again. If x is going in, first things first, we're timesing by 5. So we're going to get 5 x's. And then we're going to take 3. I'm just going to write take 3. Nothing to do there, but write down what's happening to x as it works through the function machine. Question 7, we've got some parallel lines. That's important. That's going to give us all the rules that we need to know. And we're looking to just complete the following statements. X is 55. So we're looking at that one and we're told that it's 55. And what we've got here is a set of alternate angles. So I'm just going to write that down. Alternate angles are equal. And then part 2 says y is 70. So we're told that this is 70. And what we've got here is something called corresponding angles. They're in the same place, if you like. So I'm just going to write that up here because I'm going to go off my screen if not. They're your parallel line angle facts. Corresponding angles are equal. Question 8, my mate Darren's got 20 crayons in a box. And these are how many of each colour. And then we've got a probability scale here. It says which arrow shows the probability that the crayon is blue. So there's blue. There are 8 crayons that are blue out of 20. You might be tempted to go for the biggest number or the highest arrow, but 8 out of 20 is less than a half. Okay, it's not got 10 blue, so it's got to be smaller than halfway. I think blue has to be C. We're then looking for the probability of yellow. So how many yellow crayons has he got? None. So the probability of yellow, impossible. It's got to be A. And then not black. Well, he's got 5 black. So black is 5 out of 20. And 5 out of 20 is a quarter. So a quarter along this way would be black. Not black is everything else. So not black has to be everything else, which would be 3/4. So that has to be arrow E. Part B says Darren buys 16 more crayons that are either blue or red. He puts them in the box with the 20 crayons. So if he buys 16 more and there's already 20 in there, it's definitely out of 36. He picks a crayon at random from the box. The probability that he picks a blue crayon is evens. So evens is like half and half. So the probability of a blue is going to be half of this, and half of 36 is 18. That's because 18 out of 36 is a half, and that's evens. It then says how many red crayons did he buy. Well, blue has gone from 8 to 18. So there's 10 blue altogether, or he bought 10 blue, I should say. How many red did he buy? Well, if he bought 16 altogether, then 16, take away the 10 blue, he must have bought 6 red. So in question 9, and here we've got a distance time graph. It's actually a distance from home, but we'll come back to that in a bit. It says Sarah's journey from home to a shopping centre. Okay. What assumption has been made when the graph was drawn? Well, if you look, we've got perfectly nice straight lines. And when you've got perfectly straight lines in a graph like this, what that means is she's travelling at constant speed. Wherever she's walking, she's going at the same speed all the time because we've got these perfectly straight lines. Part B, what is the distance from her home to the shopping centre? Well, here's home. We can go right up this scale to the shopping centre. We've just got to work out this number. Well, I think it's not going up in ones. 30, 1, 2, 3, 4, 5. That's no good. It must be twos. 32, 4, 6, 8, 10. Yeah, so this was 36 kilometres. Part C says, between which two times did Sarah stop? Explain how the graph shows this. Well, if we think about distance changing, if she stopped, then the distance is not changing. And if we have a look at this point here, all the way along there, her distance has stayed the same. So that's when she stopped. So now we just need to figure out this time and this time. Well, that one's easy. It's 11 o'clock. And we just need to check this time. It looks to me smack bang in the middle of 10 and 11. So that's going to be 10:30. And how is it shown on the graph? Well, you might say that that's a flat line. Better to say horizontal than flat, but they will both get full marks. Part D says we're staying at the shopping centre until 1 o'clock, and then we're travelling home and it takes 40 minutes to get home. Can we complete the graph? It's a little bit tiny, I know, but there's 1 o'clock. And if we're staying at the shopping mall until 1 o'clock, we're just going to stay still at that point. I don't know why I said mall then, that's a bit American, isn't it? Anyway, it takes 40 minutes to come home, so if it was 1 o'clock, we now need to find 40 minutes later. I think these are going up in tens. 10, 20, 30, 40, 50, 60. Yeah, remember 60 minutes in an hour. So that there, 10, 20, 30, 40, would be 40 minutes, and we'd want a nice straight line. You would obviously use a ruler down to that point. It then says, work out the speed for her journey home and give your answers in kilometres per hour. Well, if we're going to work out speed, we're going to need the distance and we're going to need the time. We already know the distance travelled because that's from the shopping centre to home, and we got that in the first part of this question, which is 36 kilometres. We also need the time. Well, we've just said it takes 40 minutes, so we can divide by 40 minutes, but it says give her speed in kilometres per hour. So what I'm going to do is just use this division and find a nicer one to get kilometres per hour. Just looking at what I might do to these top and bottom. If I divide top and bottom by 2, I'd get 18 out of 20. And then there's a little trick here. If I times top and bottom by 3, something nice is going to happen. I'm going to get, not out of 20 minutes, I'm going to get out of 60 minutes. So I need to do 18 times 3. Well, 3 tens are 30. 3 8s are 24. 30 add 24 is 54. Why did I do this conversion? Well, now I've got 54 kilometres every 60 minutes. 60 minutes is 1 hour. This is 54 kilometres per hour. Question 10, we've got some simplifying to do. So I'm looking at my t's first. I've got 3 t's and I'm taking away 2 t's. That would leave me with a single t. Then I've got 5 u's and I'm adding on 3 u's. That's 8 u's, and it would be positive 8 u's. We're going to simplify 6a times 2a squared. Well, 6 times 2 first is 12, and a times a squared is a cubed. And then part B of this question, we've got to make x the subject. So I'm going to try and get x on its own. I'll just rewrite the equation out. We've got y equals x squared take 1. If I want x on its own, then let's add 1 to both sides to get rid of this. And we get y plus 1 equals x squared. I've still not got x on its own, so I've got this squaring. The opposite of squaring is square root. And what we're left with on the left-hand side, we get the square root of y plus 1. And that equals just x. Question 11, here we've got a scatter graph. All of these grey points have already been plotted. We've just got to plot what's left. So let's just double check. We've got age and age, and then we've got height and height. Okay, so these top measurements are the across, and these bottom measurements are the up. So I'm going to go across to 3 and up to 90. Well, if that's 2, that's 4. 3's in the middle, and I'm going to go up to 90. I'm going to go across to 6 and up to 117. Across to 6, there's 100, there's 110. Just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so that there is 117. Across to 9 up to 127. Across to 9, there's 120, 125, 6, 7. And then across to 4 and up to 103. Across to 4, there's 100, 1, 2, 3. So that's the rest of the points plotted. Describe the correlation in the scatter diagram. Well, these points are going upwards, so that would be positive correlation. In part C, we've got a doctor saying to use a line of best fit and talks about a height of a 6-year-old being 95 centimetres. So for a line of best fit, we're going to have to try and cut through these crosses. So I'm just going to do a quick guess here, but it'd be something kind of like that. Again, you'd use a ruler to find like the middle of all these crosses. And the doctor says the height of a 6-year-old is 95. So we're going to need to find 6 years old. We're going to read up to my line of best fit and across, and that is nowhere near 95. That's coming out at about 115. So the question actually said, does the diagram support the doctor's statement? The answer is no. And you could just say something along the lines of, see my line of best fit, literally pointing to what you've done, or it would be more like 115 centimetres. Part D, explain why the scatter diagram and line of best fit should not be used for someone who's 12 years old. Well, we can see that we've only got data at like 8 and 9 years old, and that's exactly what we need to say. Just say that. There is no data beyond 9 years old, so we can't use this scatter diagram beyond 9 years old. Question 12, and we've got two people, Alice and Kate. My mate Kate is 5 feet and 2 inches, and Alice is 1.57 metres. And we need to see who's the tallest. So I think all we've got is conversions from inches to feet and inches to centimetres. So I think the nicest way is to go from Kate to Alice. So let's have a look. If we know that 1 foot is 12 inches, and then think about Kate, well, Kate is 5 feet, and each one of those feet is 12 inches. So I need to do 5, lots of 12, and that's 60 inches. Don't forget the extra 2 inches. So Kate is 62 inches. We then can use this to turn inches into centimetres. So we've got 62 inches, and every inch is 2.5 centimetres. So we need to do 62 multiplied by 2.5. Well, I'm going to take this bit by bit. If we do 2 62s, well, 2 60s are 120. 2 2s are 4. That's 124, just looking at those parts. If we then do 0.5 62s, well, 0.5 62s is just a half of 62. And a half of 62 is 31. If you add those together, you've done 62 times 2.5. So 4 add 1 is 5. 2 add 3 is 5. Not lined up very well there. And 1 is just 1. So my friend Kate is 155 centimetres. Looking at Alice, Alice is 1.57 metres, so now we need this in metres. Well, 155 centimetres is 1.55 metres. And we've got to answer the question. It says, Alice says she's taller than Kate. Alice is 1.5. Kate is 1.55. Is she correct? Yes, she is taller because 1.57 is bigger than 1.55. Question 13, my mate Rashid's making some cupcakes and here's his ingredients. And it's important to know that this makes 20 cupcakes. First question, how many eggs do we need to make 60 cupcakes? Well, if we look at eggs, we need 4 eggs to make 20 cupcakes. From 20 to 60, well, that's just multiplying by 3. We've got 4 eggs originally, so we need to do 4 times 3, which is 12 eggs. Part B, how much butter to make 5 cupcakes? Let's have a look at the butter. So we were at 20 cupcakes and we're now going down to 5. So to go from 20 to 5, that is dividing by 4. So what we need to do is 140 divided by 4. To divide by 4, you can half and half again. Well, half of 140 is 70, and half of 70 is 35. Part C, Rashi's got 210 grams of cocoa powder and plenty of other ingredients, so he's got enough of everything else. And he's saying he can make 75 cupcakes. Is he correct? So let's have a look at the cocoa powder. Every 60 grams makes 20 cupcakes. So let's just start penciling this out. He's got 60 grams. He can do 20 cakes. If we've got another 60 grams, he can do another 20. 60 add 60 is 180. Now I've only got 210, so let's think about going smaller. If we've got 30 grams, half in this, then he can only do 10 cupcakes. We can think about another 60 grams being another 20 cupcakes. And if we look at these numbers, they come out quite nice, because if we start adding together, 60 add 60 is 120. Add another 60 is 180. Add 30, that's his 210 grams. And altogether he can make 20, 40, 60, 70 cupcakes. And again, make sure you answer the question. It's saying, he says he can make 75 cupcakes. Is he correct? No. And this is your reasoning. Can only make 70. That would get full marks. You're working there. Question 14, we've got an enlargement to do. It says enlarge the triangle, scale factor 3. So if you take this triangle and just draw it 3 times bigger anywhere, you'll get marks for that. Okay, but we're going to try and get it in the right place using this centre of enlargement. So what we can do is just count maybe across and up. So if I count across and up, that's 3 across, 1 up to this point. Scale factor 3 means do everything 3 times bigger. So 3 across, 1 up once. 3 across, 1 up twice. 3 across, 1 up 3 times. I did this movement 3 times because of the scale factor 3. What I'm going to do now is just draw this triangle 3 times bigger. So 1 across becomes 1, 2, 3 across. 2 up becomes 2, 4, 6 up. And then diagonals just take care of themselves, just join those corners together. So that's now 3 times bigger and in the correct place. Part B, describe the transformation that maps B onto A, so coming back the other way. Well, even though it's getting smaller, it's still classed as an enlargement. So that's what we need to say first. The scale factor, well, we're not 3 times bigger anymore, we're 3 times smaller, and the way to show that is a third. Everything's being divided by 3. So my scale factor is a third, and the centre is still this point P. We're just going to write that as a coordinate, so across to -4 and down to -4. We've got Ed, my mate, he's got a card shop. He buys a card for £1.20 and sells it for £1.68, and we want percentage profit. So I think straight away I can look at what he sells this card for, £1.68, subtract what he bought it for, £1.20, And if we do that subtraction, 8 take 0 is 8, 6 take 2 is 4, decimal, 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 and 1 take 1 is 0. He gets £0.48 profit. Now if we want the percentage profit, we need to do his profit divided by the original amount. So I'm going to do £0.48 divided by £1.20. That's quite difficult, so I'm going to look for a better calculation than this. If I times the top and bottom by 10, I'll get 4.8 divided by 12. And if I times top and bottom by 10 again, I'll get 48 divided by 120. This is still disgusting, so I'm going to try and make this much nicer. If I now half top and bottom, I'll get 24 over 60. Half again, 12 over 30. Half again, 6 over 15. Divide both these by 3. I'm going to get 2/5. Just divide by 3 divided by 3. And 2/5, well, how many 5s into 2? 5s into 2 is 0. Get some digits to work with. It's actually 0 remainder 2. And 5s into 20 is 4. All that work I know, but 2/5 is certainly much easier than 0.48 1/20. So we know that this comes to 0.4. If we times that by 100 now, we've got 40%. Part B says that Ed's profit on good luck cards was £360, and this is a decrease of 20%. What's the original amount? So what we've got is a typical reverse percentage problem. What we don't know is the original amount, which we're going to call 100%. What we do know is a reduction of 20%. That's going to bring us down to 80%. And we know that that comes to 360. What we need to do is scale this 80% that we've got back up to the 100%. Well, if 80% is 360, I can work out 40%. Just halving left, halving right. Half of 360 is 180. I can do 20%. Again, just halving and halving, that's 90. Why is 20% good? Well, 20% is my original reduction. So that 20% is £90. If I do the 360, add the 90 back on, the original is 450. Talking about a sunflower growing 4 centimeters every day, and it says how many days to grow from 80 centimeters to 1.06 meters. Problem straight away, we've got different units, so let's get those consistent. 1.06 meters. To change to centimeters, we're timesing by 100, and that's just going to move this decimal point 2 places. So we've got 106 centimeters. If we now look at how much the flower is growing, well, we're going to do 106 centimeters, take away 80 centimeters. You could probably do that in your head. That's 26 centimeters. And then it says we're growing 4 centimeters every day. How many days? So I want to know how many 4s go into 26. 4s into 2 is 0 remainder 2. 4s into 26. Well, 6 4s are 24. So it'll be 6. And I'm just going to put remainder 2. It's going to be 6 and a bit days. And it actually says more than this. So it's got to be 7 days. Part B says if the sunflower grows at a faster rate, how would this affect your answer to part A? Well, if it's growing at a faster rate, it would take less days. Question 17, this is a probability tree. We're talking about red counters and blue counters, and my mate Jack picks a counter and then replaces it. Well, good news is if we're putting the counter back in the bag, then all these probabilities are going to be out of 7, because there's always 7 counters in the bag. If we look at these 2 branches, well, we've got 4 7s here. This must be everything else, which is the 3 blue counters, 3 7s there. And then these branches are just going to repeat up here. So 4 7s and 3 7s. And then it will be the same down here. We're going to have 4 7s for red and 3 7s for blue. These branches match the start. These branches match the start. Part B says, work out the probability that we get 2 red counters. So we're going to travel along this branch to red, and then we're going to travel along this branch to red. And all we need to do is sweep up those probabilities as we go. That's the probability of red and red. 2 red counters. So let's pick these probabilities up. We've got a 4/7 and a 4/7, and we're working along the branches. We need to multiply those together. Multiplying fractions is easy. 4 times 4 is 16, and 7 times 7 is 49. There's your final answer. We've got some information about theatre tickets, and we've got normal prices here. It says £80 for adult, £40 for a child, and then there's a sale on, and these are reduced by 15%. My mate Adam's buying 2 adult and 1 child at the sale price. So there's lots of ways to do this. What I'm going to do first is just work out what 2 adult and 1 child ticket costs. Well, we've got 2 adults, so we've got 2 lots of 80, which is 160, and we've got a single child, so 1 lot of 40, which is 40. If you add those together for those tickets, it would originally cost £200. At this point, I'm going to reduce by 15%. I could have reduced by 15% first, but I would have had to do it twice, so I may as well work out the total and then reduce by 15%. So let's find 10% of 200. We'll divide by 10, take a 0 off. That's 20. 5% would be half of this, which is 10. And that allows me to work out 15%, which is just these two added together. 10 and 5, 20 and 10, £30. So the reduction is £30. So let's figure out what my mate Adam pays. He would have paid £200. We're going to remove the 15%. The actual money that he pays, 200 take 30, is £170. It does say then that a 2% booking fee is added to the total cost of the tickets. Well, this is now my total cost. What I need to do is find 2% of this and add it on. So let's do that. 10%. Again, divide by 10, take that 0 off, is £17. I can now come down to 1%. Again, dividing by 10, I'm going to get £1.70. When I've got 1%, I can get 2%. Just double this, £1.70, add £1.70. That'd be £3.40. That is what's added on to the total cost. So what I'm going to do is 170 added to £3.40. The final amount that my pal Adam pays is £173.40. Question 19, we've got quite a lot of information here about what's going on. So we've got people having a driving test. 40 of the group were men and the rest of women. And then it talks about people who pass the test, and it says 3/5 of the men pass. So I'm going to stop there and just pull that information out, because if we've got men, then that's 40, and 3/5 of those pass. So I'm going to write 3/5 pass, and if I do 3/5 of 40, that's the men who pass. So 3/5 of 40. 40 divided by 5 is 8. And then 8 times 3 is 24. So there are 40 men and there are 24 men who pass. It then goes on, I'm ignoring this little bit. The number of men and women that passed is the same. So we know that there are 24 women who pass. And then if I go back up to this middle line, it says 2/3 of the women passed. So 2/3 of the women passed, 24 women pass. 2/3 pass, 24 pass. 2/3 is 24. So I'm just going to work this backwards. We know that 2/3 of the women is 24. So there's thirds, there's 2/3. Not great, but this zone here is 24. 2/3 of all the women comes to 24. That must mean there's 12 there, 12 there, 12 there, 12, 24, that's right. And then this must also be 12. The question is, how many women? Well, it's right here. 12, 24, 36. And then question 20. Here we've got an angles problem, and we're looking to find this angle here. But straight away, I've got something called vertically opposite angles, and I know that those angles are the same. And we've got algebraic angles, so I'm going to write myself a little equation. The angle on the left, x plus 20, is the same as the angle on the right, 3x minus 50. And what we can look to do now is solve this equation. Whenever you've got x's on both sides, always get rid of the smaller x's first. So take away the single x, and we're left with 20 equals 3x take x is 2x, and we've still got to take 50. Next step would be to add 50 to both sides. And we end up with 70 equals, that's gone away, 2x. Final step, divide both sides by 2. And we've got x equals 35. We know now that this x here is 35. That's not the actual question. We're looking to find y. But what I can do is say, well, if that's 35, this angle becomes 35, add 20. 35 add 20 is 55. So that angle there is 55 degrees. And we can now use that to find y, because all of this is sitting on a straight line, and that's going to add up to 180. So y would be 180, take away 55. We can't do 0 take 5, so let's borrow. 10 take 5 is 5, 7 take 5 is 2, and 1 take 0 is 1. Angle y is 125 degrees.